This is chapter 6, problem number 4. All right. Here is an object. This object, instead of the weight, instead of giving you kg, it says 1200 Newton. Okay, so mg is equal to that many Newton. Okay, let's look at the free body diagram. Without any other external force, because it's not moving, that means there must be another force in the opposite direction to cancel it, and that is the normal force. Okay, but that's not what the problem asked. The problem asked, all right, if you push it this way, okay, if you push it at a constant speed, what do I mean by that? That means it's not accelerating. When it's not accelerating, that means the net force is equal to 0. There must be another force pushing in the opposite direction, and that's the frictional force. So when you push it, when this one moves in a constant velocity, there must be one force and the other force equal magnitude pushing it from the opposite direction. So this force is given is 230 Newton. That means the force pushing here is also 230 Newton. Okay, so if you push with 230 Newton for a distance of 5 meters, how much work? So work is equal to force, that is 200 and, well, I'm going to write down the formula. If you see this formula many times, then you are going to remember it. Force times distance. The force is equal to 230 Newton. Distance is 5 meters. So that is going to give me 1150 Newton meter. So Newton meter is joules, 1150 joule. Okay. All right, so let's look at this way. If you're going to put, instead of pushing it in this direction, you're going to push up at a constant velocity. That means there's no net force. So pushing it up, you have to spend 1,200 Newton in order to push it up at a constant velocity. All right, so if this is a force, so work is equal to force times distance. If you push up 5 meters, that means you have 1,200 Newton times 5 meters. That would be equal to 6,000 joule. Okay, so that means if you push up, you have to spend that much energy. The lucky number for this problem is 8.